All right, today's lesson is about sigma notation. A little departure from what we were doing earlier, but it's taking a series and representing it using summation or sigma notation. A series is defined as the sum of the terms of a sequence. The sequence can be given as actual terms or as a function. I have an example of a sequence here for you. All right, and we've got 3 plus 5 plus 7 plus 9 plus ... And it could continue. It can be an infinite series or it can be a finite series. All right, so find the sum of the following series. All right, 5 plus 2 plus -1 plus -4 plus -7. All right, and you just basically add these all together. 5 and 2 is 7. All right, -1 is 6. And then -4 is 2. And then -7 is -5. And that just happens by adding those all together. Okay? Now, a series can be represented using summation notation. This is also known as sigma notation. All right, so, and that's what this is. This is the Greek letter sigma, capital sigma. All right? So, n equals 1 to 5. And then it has 2n plus 1 for the expression next to the sigma. All right? What this tells me to do is it wants me to actually add the things together from 1 to 5. So instead of n's, I'm going to have 1. And then in the next term, guess what I'm going to have? 2. And then in the next term, what do you think might follow that? 3, sure. And then in the next term, you're going to have a 4. And I've ran out of room here a little bit, so I'll just bring this down. 2 times 5 plus 1. Okay, there we go. All right, and then you need to simplify inside the parentheses and then add those terms. All right, so the first one is 2 times 1 plus 1. 2 plus 1 is 3, so that's going to be, let's do it down here. 3. And then 2 times 2 is 4, plus 1 is 5. 2 times 3 plus 1. 2 times 3 is 6, plus 1 is 7. 2 times 4 is 8, plus 1 is 9. And 2 times 5 is 10, plus 1 is 11. There we go, okay? And then, now since these are all like terms, they can be added. And like when I add my golf scores, these are typical golf scores for me, 9 and 11, they make 20. And 7 and 3 make 10. Right, so I'll take those, right? 10 and 20 is 35. Yeah, or you can just sit and add them in order. Either way works. Okay? Find the sum of the following series. This time I have 2 to the k minus 1, and I'm doing from 3 to 6. So it is going to be 2 to the 3 minus 1 plus 2 to the 4 minus 1 plus 2 to the 5 minus 1 plus 2 to the 6 minus 1. So where do I start the series? I start the series down here, right? I plug in 3, then I increase by 1 until I get to 6. I take k and substitute the values 3 through 6 in there. So this first one here is 2 squared, plus 2 to the 3rd, plus 2 to the 4th, plus 2 to the 5th. All right, now 2 squared is 4, 8 for 2 cubed. 2 to the 14th is 2 to the 3rd times 2, so that's going to be 16. And then 32. And then I add my scores together. All right, and again, I'm going to group them conveniently here. I'll do convenience grouping. 8 and 32 is 40, and 16 and 4 is 20, so that gives me 60. There we go. All right, next example here. Oh, of course, we have to have some trig in here, don't we? Find the sum of this following series. I equals 1 to 4 sine of I pi over 2. All right, so I'm going to really get sine, and in this case, I is just a variable. So you're going to take the I out and replace it with the numbers 1 through 4. So it's going to be sine of pi over 2 plus sine of 2 pi over 2 plus sine of 3 pi over 2. You know what? Maybe I should take this stuff and put it down here where I'm going to have room to put it all in. That's a little neater, I think. Plus sine 4 pi over 2. There we go. And now we simplify some of these, right? This is just going to be the sine of pi. This one is the sine of 3 pi over 2. This one is the sine of 2 pi. And I'm going to use our old friend the unit circle to come up with these values. Sine of pi over 2. There we go. Recall, unit circle looks like this. Here is 0. Here is pi over 2. Here's pi. This is 3 pi over 2. And this is also 2 pi. And since I'm doing the sign, that's going to be the y-coordinate of these points on the unit circle. This is 1, 0. This is 0, 1. This is -1, 0. And this one is 0, -1. So I'm using the y-coordinate. Sine of pi over 2 is 1. The sine of pi is 0. Sine of 3 pi over 2 is -1. And the sine of 2 pi is 0. When I add those all up, 1 plus 0 is 1, minus 1 is 0, 0 plus 0 is 0. So I have a sum of 0 for that one. Okay, moving on. Now, in this case, I've got an I in here, and I've defined I to equal the square root of -1. That means it's the imaginary number in this case. And n is my variable. Okay, so what this is going to equal is going to be 3i to the 0 plus 3i to the 1 plus 3i to the second plus 3i to the third plus 3i to the fourth. And a lot of times you'll see this question asked to say, to find it in simplest a plus bi form. Okay, that's the complex number, is a complex number there. All right, well, anything to the 0 power is 1, so that's going to be 3 times 1. And then I to the first power is I, right? And again, we can use the I clock if you like, right? And then I squared was -1. And then I cubed is -I. And then I to the fourth is back to 1 again, right? And remember, I told you about the I clock here, right? Here's the values 1, I, -1, -I, right? So I to the 0 is right here is 1, I to the first is I to the second is -1, I to the third is I to the fourth is 1 again. So what's that going to be? That's going to be, let's see, let's combine some like terms here. 3 minus 3, 3 plus 3i minus 3 minus 3i plus 3. Okay, so then I'm going to cross out this up here. The 3i and the minus 3i are going to cancel. And then let's see, the minus 3 and the plus 3 cancel. I'm left with 3 for my answer. If it wanted in simplest a plus bi form, I would say plus 0i. But the instructions didn't say that originally. All right, they want me to find the sum of the following series. I've got j minus 4 exclamation point. Now, some of you remember that's going to be factorial. And that's going to be something like this here. We're going to have 7 minus 4 factorial plus 8 minus 4 factorial plus 9 minus 4 factorial plus 10 minus 4 factorial. Then what that gives me is 3 factorial plus 4 factorial plus 5 factorial plus 6 factorial. The reminder, 3 factorial is 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. Any number factorial is that number multiplied down to 1. All right? 3 times 2 times 1 is 6. All right, and then this one's going to be 24. And then the next one is going to be, you know what, I just here show you on this also. Let's get out of here. All right, clear that. You can find the factorial button on your calculator. 5, all right, and then you go math, and it's probability. And you see choice 4 there is 5 factorial. It's the factorial button there, and you got 120. Okay, and by the way, also, if you know 5 factorial, 6 factorial is really just 6 times 5 factorial, so I can do that as a shortcut. 6 times my answer, 720. And then you add those numbers together, right? 720 plus 120 plus 24 plus 6. And you get 870. Okay, so that's how you can take something that's in sigma notation and evaluate it. A little bit harder. harder is representing a series using sigma notation. Basically, you have to figure out how you can use sigma notation and get the series that is given to you. All right, so 3 plus 6 plus 9 plus 12 plus 15. You know, there's a lot of ways to do this, all right? But when I have this one here, this is actually an arithmetic series. I'm adding 3 each time, all right? And when I add 3 each time, what I'm actually doing is I'm taking n and I'm multiplying it by 3. So I'm going to do the sum from n equals, and I usually like to start with 1 or 0, all right? And let's think about this. What do I do to 1 to get 3? 3 times 1, 3n, right? Because 3 times 1 is 3. And this one is 3 times 2. And this one is 3 times 3, 3 times 4, 3 times 5. So I have to go from 1 to 5 for my sigma notation. And there it is right there. That is that series represented in sigma notation. How are you typically going to see this on a Regents exam? Well, like this, a multiple choice question. Which expression is equal to 2, 6, 12, 20, and 30, right? The way you can do that is you can take each one of those and kind of expand the sigma notation, you know, using what you have. So let's try that. Let's try A. Yeah, we'll try A first, right? And this can seem a little tedious at first, but it's not really that bad. 2 plus 4 times 0. Okay, and that's going to give me 2. That works for the first one. So far, so good. And then 2 plus 4 times 1. And that's going to give me 2 plus 4, which is 6. Hey, maybe it's the first one we tried. Now remember, don't assume that you have it just because it works for the first couple, because it might start to fall apart after that. Oh yes, 2 plus 8 is only 10, right? Which is not 12. So it is not choice A. All right, and then you can move on and you can try choice B. Let's extend this page here and move this out of the way. And some of these you can find that just aren't even going to work for like the first one, right? Not even going to work for like the first one. Like let's look at this D here, all right? 0 squared, this would be like what? It would be 0 squared plus 0. Well, that's going to give me 0. That didn't even work for the first one, so that one's eliminated, right? If you look at this next one here, you're going to have 1 times 2, right? That's going to be 1 times 2, which is 2. And then the next one's going to be 2 times 3, which is 6. Wait a second, and then we got 3 times 4, which is 12. 4 times 5, which is 20. 6, 5 times 6, which is 30. It is choice C is the correct answer. All right, and that you can do like kind of by working backwards. All right. Okay, well, best of luck. Remember, replay, pause, rewind. Come see me after school also if you have any questions. Thanks, good luck.